So hello everyone, good afternoon. So thank you for joining us at Data Plus AI Summit today. My name is Heya Ouyang, and I am a senior associate researcher at Nikon's Mathematical Science and Research Lab. Today, I am very excited to share with you how Nikon is scaling our demand forecasting. So especially how we automated the sales planning for our camera accessories business using Databricks. So the scaling, the forecasting, and automating is the three keywords for today's presentation. I think these three words well summarized what kind of challenges we faced and also how we address them. My colleague Nishino is here with me today, supporting me just off the stage. And our teammate Uebashi, he's back in Japan, so cannot join us in person today. So just a quick note that I haven't had a lot of opportunity to practice my English in the past few years. So if you hear a little Japanese or Chinese slip out, or I just forgot to say something in English by accident, please, especially in the QA section, please forgive me, I will try my best. Okay, so that's all for the intro. So here is what we will cover today. So first, I will give you a quick overview of Nikon as a company and also the division that and the team I am part of. And I will also explain why demand forecasting is so important for our camera accessories business. And next, I will walk you through our development journey from the early inspiration to the transformation we achieved. And next, we will take a closer look into the framework we built with Databricks, and specifically, I will dive into how we apply MLflow in this use case. And finally, I will share the result we saw, highlight some of the key lessons we learned along the way, and wipe up with a quick look at what we are going to do next. So let's begin. Okay, so when you hear the name Nikon, you probably think of cameras, and for a good reason, I believe. So we are a global leader in high-end cameras and lenses with a very strong share in the professional market. So our innovations in cameras even reaches beyond the Earth, I would say. Some of you might heard that we have been working with NASA for many years. So, and we are now working with NASA to provide a specially adopted Z9 camera for the Artemis lunar mission, I believe. And recently, on the other hand, our collaboration with RAD also marks our move into the professional video camera market. So maybe soon in the future, you will be able to watch a movie that is shot by a camera that with one of our technologies on it. But our expertise in optics and positions goes far beyond just cameras. So we have, Nikon's solution is play a key roles in many different fields, including semiconductor manufacturing, healthcare, and also the advanced measurement systems. So all of these works, we are helping to drive the breakthrough in a wide range of industries. Okay, so then I would like to take a moment to briefly introduce the division and the team I am part of. So I work in the Advanced Technology Research and Development Division, which oversees several global research centers and labs. So for example, here in the US, we have the Nikon's Research Corporation of America. So I believe it's located in Belmont, so just an hour drive just from here. And on the other side, my home base, though, is the Mathematical Science Research Laboratory, which is located at the Nikon's headquarters and the Innovation Center back in Tokyo. So our lab is made of 4 different specialized teams, which we focus on areas like mathematical modeling, simulation, data science, machine learning, robotics, and image processing, etc. So this collaborative environment is where we tackle some of the Nikon's toughest technical challenges and help to drive the new innovation forward. Okay, to support all of these innovations, we built a very strong partnership with Databricks. So today, just in my team, so there's 10 people in my team, we have about 10 active projects running on Databricks, and we're maintaining 19 resource groups and workspaces. I don't know if that's a lot, but that's a lot for us, I would say. And our Databricks powered projects covers a wide range of areas. So from the productivity improvement back in the factory for the production line, and to the marketing and supply chain optimization, and even the Gen AI. So we have a big project using the Gen AI to do the accident analysis for the product design. So among all these topics, demand forecasting, which we will be covering today, is a key pillar of our work with Databricks. Okay, so next I will go into the main part of this presentation. So when you think of camera, you probably picture the main device, like just in the middle of these pictures. But the accessories like flashes, cables, adapters, batteries, they are also essential to our overall user experience. So my colleague Nishino, he is holding a Z5 II camera. I believe it is our latest full-size mirrorless camera that just launched last month. But onto that camera, you can see a big speed light and also a big battery pack onto it. And also with this little blue strip, and which said the Nikon's professional service. So all of those are examples for accessories we provide. And besides that, Nikon offers nearly 500 different kinds of accessories, serving both the professionals and the hobbyists around the world. So accurately forecast the demand for all these accessories is very important for both the customer satisfaction and for our operational efficiency. Okay, but making sure these accessories are available when and where they're needed is not always an easy task. So first, there is a very huge diversity across the categories comparing to the cameras and lenses. And many accessories, they just have very long lead time from our suppliers. And for the accessories, many of them are really in low volume, but still they are very important to our customers. So you do want to have the stock when someone really needs it. So while on the other hand, you can imagine that there is attached relationship between the main body, the primary product, the cameras, and some accessories. And on the top of all of these, the demand for many of these accessories are actually very picky. So you might have like 0 sales for months and suddenly experience a surge. So all of these factors make the traditional demand forecasting methods really challenging in this specific use case. Okay, so adding to the complexity, Nikon, we consolidated the sales plans from 10 different global subsidiaries and covering nearly 3,000 SKUs. So after collecting all these plans from the sales subsidiaries, we place order with our suppliers and then distribute the accessories to each region after they arrive. So most of these SKUs, they have very low average monthly sales. So usually less than 5 units per month. And on average, each SKU, they have 0 sales for more than half of the months, half of the years. But we still need 18 to 24 months of sales plan, mainly because of the long lead time, especially since the COVID. And the planner around the world, they spend over 30 hours per month on this specific task. And the accuracy of those accessories are mostly just unknown before, since there's really there's not much time for the planners to double check all the SKUs in details. But what we do know is that the planners tend to overestimate demand as you can imagine, the planners are from the sales subsidiary, so they really want to avoid stock out and they want to sell whenever they can sell. But that usually leads to the excess inventory. And on the other hand, underestimate, combining with the long lead time, means that we cannot fulfill customers' needs on time. So getting the right balance between those under and over is a real challenge, not only in this case, but I believe in demand forecasting in general. Okay, so our journey began with early attempts at very simple automation. So we start with AutoML and other very classic machine learning methods, but they could not handle the diversity of the accessories, especially for the low demand items. And then we try segmentation. So we try to use time series statistical model for the independent accessories, and also for the, we use the machine learning methods for the items that depend on the primary products. So for the dependent one, we also try to apply, try to use the camera sales and camera sales plan related as a variable, so that hoping that we could increase the accuracy. But the fact is that we try a lot, but the accuracy was still low, and the main challenge was still diversity. So it turns out that some of the accessories, their cells are closely related to the camera cells, but there's just some of them that are not connected at all. So this make it really difficult for any single methods to perform really well across the board. And then we, based off all of these situations, we decided to shift our focus to relatively high volume items. So hoping that we could automate where it could have the most impact. So along the way, we just realized that different SKUs, different accessories, they need different models. There's no one-size-fits-all solutions in this case. So we built a system that can dynamically evaluate prediction accuracy across multiple statistical and machine learning models, and mainly using the past sales data from both the accessories and the cameras. And it automatically selects the model that with the best performance for each SKU, and then generate the forecasts. So for the relatively low volume items, our strategy is to aggregate the global demand, and then we do the same thing, use the same methods to generate the forecast, and then distribute the forecast to each region by share. And we also added anomaly detection and features that auto-fix the outliners to make everything on the right page. So this approach allows us to better match the unique demand pattern of each single SKUs and to improve the overall forecast accuracy. And with this approach, we are able to automate the forecast for about 76% of the SKUs. So cutting the planner's workload from over 30 hours per month to just 3 or 4. And our accuracy also improved. So now 57% of the SKUs are within plus minus 40% of the error margin, which is almost the same as the human planner. And most importantly, we saw fewer large mistakes compared to the manual forecasts. However, well, we think we are making a good progress, but that's not what the planners think, because we still couldn't automate the forecast for the remaining 24% of the accessories, and most of these accessories are actually super low volume ones. So the planner, they still have to handle those somehow by hand, and even though they're just not as important. Another challenge was, I would say, trust. So because the planner, they have to handle many of those by hand, they will just prefer to double check everything, especially for the high volume ones and for the crucial ones. So as a result, the system was not fully adopted at that time. It didn't cover all, and it did not fit perfectly with the planner's preference and their workflow. So while we think we made a good progress, there's still more to do to scale the automation to all accessories and make the system truly useful. So to scale further, we simplify our strategy for the super low volume items. So after all, you have to admit that no machine learning or statistical method that can reliably predict the extremely low volume demand patterns, like a sequence of 0, 0, 1, 1, 0, etc. So essentially, after careful verification, we decided to set the future demand, the future 6 months of demand, to be equal to the total demand of the past 6 months. So it's really simple. So if we are doing the 18 months of sales plans, it will be 6 times 3. If it's 24 months, it will be 6 times 4. And based on the feedback from the planners, we decided to set the first 2 months plans to be fixed, so that it should be equals to the plan from the last month. And the remaining months can just be distributed evenly. So it is simple, but it actually worked. So now 99% of the accessories are covered with an accuracy that is comparable to the human planner. And it is easy, it is fast, so adding almost no extra calculation time. And it is, this kind of accuracy is actually good enough because usually the SKU for all the accessories, they have the inventory buffer. And most importantly, this approach fit our planner's workflow and their preference. And because it covered everything, so now the planner can finally step back from the manual forecast and entirely. Okay, so that's half of the way. So let's look at how it comes together at that time. So we perform all our development journey inside the Databricks. And with a series of Databricks notebook, we gather data from multiple local and on-premise sources. And we then ingest and clean the data, auto-select the model, generate the prediction, and process the output, all within a single workflow. And at the end of the pipeline, everything is set up to feed directly back to our own planning system for the system for planning and also ordering, as well as into the dashboard for the planner. Okay, so to conclude the first half, our framework now scales seamlessly across Nikon's entire accessory portfolio, and the Databricks has been a key enabler. So we built this proof of concept model, and that is enabled by Databricks for both the forecast accuracy and also the scalability. However, some challenges remains, especially moving from we as the R&D side to the full automation in production. So the system integration is usually very costly and time-consuming. And in the past, it's just not every project has the chance to go into that pilot stage because of that. And for us as developer to achieve the real world impact takes more than just a working model, the proof of concept. And when a project does reach the integration stage, it often goes beyond our direct reach. So at that time, it is very hard for us to continue to tuning the parameter or to monitor the performance at that time. So, and last year, my colleague and we attend this very summit for the first time. And we realized that we were only scratching the surface of what Databricks can really do. So we attended many sessions, and we learned about use case from many other companies. And that really opens our eyes for the new possibilities. So this experience inspired us to apply more of the MLOps concept, and also to explore more of Databricks features, including Unity catalogs and MLflows, etc. And with these tools and practices, we can finally automate all the way from the development to deployment, and continuously monitor the performance of our model, even after the integration. So MLOps has truly been a game changer for us. I am very sure that many of them have already familiar with the concept, maybe even more than I do. So I will not go into any details here, but with Databricks, we have set up an automated pipeline for demand forecasting that takes our models all the way from the development to the production. And this allows a faster integration than before, a better model management, and also a more reliable production stage. Okay, so here is what our current framework looks like. So we start by gathering data from a variety of sources, which is then put onto the Azure blob storage. And then we move to the Azure Databricks workspace, where we prepare our data, ingest and clean the data, and organizing all of them into a bronze, silver, and gold delta table. And at the development stage, we experience with different statistical and machine learning models. So we use MLflow to keep track of the experiments and the parameters, and to compare the metrics, and more importantly, to monitor the performance of each model for each SKU. So in this environment, it's all about flexibility. So we can update our code, we can run tests, we can adjust the features, all in a relatively controlled environment. And when we are ready to move to the production side, or what we say a release stage, we transition everything into a more automated and more reliable workflow. So now the system manage the entire process end to end. So from the data updating to model selection, and also to the generating for forecast and pushing the result back to our own planning system, and also to the Power BI dashboards. So we use Databricks workflows for the automation, also including scheduling the jobs. And we use MLflow, in this stage, we use MLflow to monitor the prediction accuracy. Okay, so let me share a bit more about how we use MLflow in this project. So for us, MLflow is all about making the model monitoring simple and efficient. So in both development and production stage, we rely on MLflow to keep track of key details and to provide clear visualization. So this visualization will help us to spot problems and to better understand our model and the result at a glance. My apologies that the diagram on this slide is a little bit busy, so let me walk you through it. So during the development stage, as we test different models, MLflow keep track of everything. So from the past cells to the model setting, the training results, the performance of each model for each SKUs during the model selection. So this makes it easy for us to compare the model to quickly identify which model are performing well, and more importantly, which one are not performing well. So as you can see at the top right of this page, we have an example of a visualization of the RMSE of different models across the timeline. So absolutely, this one is from a simulation, so it's not the real-time things. But the overall accuracy in this case is actually decreasing for all the models. So we know that we need a bit of analysis on what just happened. And that is for the development stage. And once we move to the production stage, MLflow continue to monitor, so it mainly monitor the prediction accuracy as the actual cells comes in, so that we can see if the model performance is dropping or there's just something that needs our attention. To summarize, so in short, MLflow for us, it's all about transparency and flexibility. So we can use it to improve our forecast significantly and also to respond quickly if whenever things change. Okay, so now our entire framework is fully powered by Databricks, so leveraging Unity Catalog, Sparse, Delta Lake, MLflow, and the Databricks workflows. And the result is a robust, scalable system that can empower both our planner and us as the developer. And now, this is a timeline for a very simple timeline for the implementation. So this system is now ready for the implementation, so we're doing a lot of testing over the past few years and gathering the feedback from the planner all around the world. And we expect to have the full-scale operations I believe, in the coming August. And the framework has also become a reference model for how to apply Databricks in our day-to-day R&D process. So that I believe in the future it will be able to continue to inspire other projects across Nikon's research divisions. Okay, so to wrap up, what have we learned from this journey? So first, when it comes to forecasting a very diversity of products like accessories, adaptivity is very crucial. So there is no one-size-fits-all solutions, and you probably just need different strategy for different products. And sometimes, to be honest, you just don't need the most advanced model to get the job done. And secondly, to truly scale, you have to commit to the full automation. So if you only automate part of the process, it is very possible that, very likely that just like us, that you will end up to have a system that does not get used. And finally, have everything in a single platform. So from the data preparation to the model development, and from the development to the production. So all in a single platform is quite enough for us for the full automation. So, and this end-to-end integration has made it possible for us to scale efficiently and deliver real-world values to our planners and our business quickly. So in short, be adaptable, go all in the automation, and for us, it is very efficient to keep everything unified on a single platform. Okay. So looking ahead, we still face some challenges. So predicting highly sparse demands remains really difficult for us. We are trying to figure out some ways to deal with those items, either using demand forecasting or some other operational ways. And also for auto-logging with MLflow, while it's really helpful, can sometimes slow a little bit of the overall performance. So we're thinking about improving the overall efficiency of using the MLflow, not only in MLflow, but also we are thinking about maybe trying Sparse API or trying the distributed calculation or trying some kind of UDF. So all kinds of things in order to improve the overall performance of the deployment. And we also lack of explainable AI feature, which if we have it, it will be very helpful for us to justify the forecasting results to the stakeholders. And our future plans include integrating more external data so that we can make the forecast more robust. And we are also thinking about leveraging MLflow for continuous development more. So now, since we only forecast once a month, so it is still okay for us to do some parameter tuning after the deployment and even in the production stage. But maybe in the future, if we want to do the forecast more frequently, for example, once a week, then I would say it would be better if we shift most of these tuning into the the development stage, and then smoothly transfer it into the production stage, transfer the best features and the best setting into the production stage. And last but not least, I believe this will take many years, maybe 5 years, maybe 10 years, but our ultimate goal is to build a fully automated end-to-end supply chain optimization system that could connect the not only the demand forecast, but the inventory, the sales and operations, logistic, or maybe even the production plan back inside the factory, and also the scheduling in the factory. So all together. So I believe this making the optimization, this will absolutely make the optimization of the entire process the most smarter and efficient. Okay, and thank you for your attention. So before I take any questions, I believe, yeah, just a moment. I believe your feedback is very important, so please take a moment to complete the survey. I don't know if you can do it now, maybe after the section inside the app. That would be very appreciated. Okay, so, and thank you for your attention, and we are ready to take any questions.